Hey guys, so we are back with our Factoring 101 series, and as a quick recap, in our previous episode, we learned how to factor perfect square trinomials. But in this episode, we are going to be learning how to factor trinomials with two variables. So if this is something you struggle with, keep watching. Alright, so when it comes to factoring trinomials with two variables, we're going to be focusing on trinomials in the form of ax squared plus bxy plus cy squared. Now keep in mind, the two variables that you deal with might not always be x and y. Sometimes they'll be a and b or u and v. I just chose x and y because they're pretty common. But when it comes to factoring these trinomials, it's going to be very similar to how we factor trinomials with one variable. And there's going to be two cases. In the first case is when a is not equal to 1. When a is not equal to 1, we will factor it to become x plus p times y times x plus q times y. Now, in order to identify the values of p and q, it's going to be very similar to how we do it with one variable. And we want to focus on the last coefficient c and the middle coefficient b. And we want to make sure that when we multiply p and q, it'll give us the value of the last coefficient c. And then when we add p and q, it'll give us the value of the middle coefficient b. The second case is when a is not equal to 1. Now when a is not equal to 1, we will initially factor it to become ax plus p times y times ax plus q times y. And the value of a represents the leading coefficient a of the expression. And this time to figure out the values of p and q, we're going to be focusing on our leading coefficient a, our middle coefficient b, and our last coefficient c. And we want to make sure that when we identify p and q, we want to make sure that when we multiply p and q together, it'll give us the value of a times c, and then when we add the values of p and q together, it'll give us the value of our middle coefficient b. Now take note, I said initially, so when we initially factor it, we want to put it in this form, but there are going to be some additional steps that we will have to take where we might have to factor either one or both of the groupings furthermore. But with that being said, let's jump to our first example. Okay, so for our first example, we are given the expression x squared minus 5xy minus 36y squared. So to factor this, what I usually do is I use this method called the x factoring method. You've probably seen me do this before if you've seen my previous videos. But essentially what we're going to do is we're just going to create an x, and what we want to do is basically fill up all the spaces of the x. So at the top of the x, what we're going to do is put our last coefficient, negative 36. And at the bottom of our x, we're going to put our middle coefficient, negative 5. And what we want to do now is fill up the sides of the x. And in order to do that, we are going to find two values that will both multiply give us negative 36 and add give us our negative 5. So to figure this out, what I recommend is just to focus on your top value, negative 36, and figure out some combinations that we know will multiply give us negative 36. So some things I can think of is 12 and negative 3. We know negative 12 and 3 would work, 9 and negative 4 would work, and negative 9 and 4 would work. And once we figure these combinations out, we want to see which one is going to also add to give us our bottom value, negative 5. So if we do 12 plus a negative 3, that will give us a positive 9, which is not equal to negative 5, so we'll eliminate that. If we do negative 12 plus 3, that will give us a negative 9, which is not equal to negative 5 again, so we'll eliminate that. 9 plus a negative 4 is going to give us positive 5, which is not equal to negative 5, so we'll eliminate that. And then if we do negative 9 plus 4, that will give us negative 5, which works. So because negative 9 for both multiply give us negative 36 and add give us negative 5, we will use that to put in the sides of the x. So we'll put negative 9 and 4 in the sides of the x. From here, we're now going to factor it. So since the leading coefficient of this expression is 1, we're going to factor it in the form of x plus p times y times x plus q and y. And what we're going to do is sub in our negative 9 and 4 into the p and q. So when we do that, it'll become x plus a negative 9 times y times x plus a 4 times y. And we'll clean that up, and it'll leave us with x minus 9y times x plus 4y. Or you can do x plus 4y times x minus 9y. Order does not matter. And that is the answer, and that is how you would factor this expression. So let's move on to our second example. Alright guys, so for our second example, we are given the expression 7x squared plus 10xy plus 3y squared. So the first thing we're going to do is create our x, and at the top of the x, notice that our leading coefficient is 7. So what we're going to do is take that 7 and multiply it to our last coefficient, 3. And we're going to take their product, which was 21, and put it at the top of the x. At the bottom of the x, we're still going to put our middle coefficient, which is 10. And now we're going to try to figure out what goes in the sides of the x. So to do this, let's just focus on our top value, 21, and figure out, okay, what are some pairs we know will multiply to give us positive 21? And some pairs I can think of is just negative 7 times negative 3 and 7 times 3. Now we want to see which of these pairs is going to also add to give us our bottom value, 10. So if we did negative 7 plus a negative 3, that will give us negative 10. So we'll eliminate that. But if we do 7 plus 3, that'll give us positive 10. So the pair that works is going to be 7 and 3. So we're going to put those in the sides of our x. Now we're going to factor this. So because our leading coefficient is not equal to 1, we're going to factor it in the form of ax plus p times y times ax plus q times y. And what we're going to do for the a, we're going to sub in our 7. So it'll become 7x plus, and then we're going to sub in our 7 and 3 into the p and q. So it'll become 7x plus 7 times y times 7x plus 3 times y. Now from here, we're going to have to take an additional step, and what we want to do is we want to factor either one or both of these groupings. And if you look at our first grouping, we have 7x plus 7y, and we can actually factor out a 7, and when we do that, it'll leave us with x plus y. For the second grouping, we just have 7x plus 3y, which isn't factorable, so we'll bring that down. And once we do that, what we can do is disregard whatever we factored out. So we're just going to cancel out that 7 and kind of like get rid of it and just leave what's left, which would be x plus y times 7x plus 3y. And that is the final answer. So now let's move on to our final example. Alright guys, so for our final example, we are given the expression 9m squared plus 36mn plus 32n squared. So the first thing we want to do is create our x, and what we want to do is figure out, okay, what's going to go in the top of our x. So notice that our leading coefficient is 9, so what we're going to do is take that 9 and multiply it to our last coefficient, 32. And 9 times 32 is 288. Don't worry, I did this in my calculator. So we're just going to put the 288 at the top of our x. At the bottom of our x, we're going to put our middle coefficient, 36. And now what we're going to do is try to figure out, okay, what's going to go in the sides of our x. So remember, what we want to do is just focus on the top of our x, which is 288, and see what pairs will give us 288. Now this value is a little large, and it's probably going to be hard to figure out what pairs will multiply to give you 288 at the top of your head. So I have a little trick that you can use in your graphing calculator in case you struggle with this. If you want to skip this, I'll put the timestamp. You can skip too if you don't really care for this. But what you're going to do is in your graphing calculators, you're going to go into y equals. And what you're going to do is just put the value of the top of the x and divide that by x. So you're going to put 288 divided by x. And then what you're going to do is press second graph, and you'll be led to the table. And essentially what this does is it provides you all the different pairs that will multiply to give you 288. It's ideal to find the pairs that are whole numbers because it also includes pairs that are like decimals and stuff of that sort, but you want to look for the first pair that's whole numbers. And the first thing I get is 16 and 18. So I'm going to write that down. So I'll write, okay, 16 and 18 is a pair, and then we can also do negative 16 and 18, negative 18, negative 16, negative 18, because that'll also give us 288. The next pair I see is 24 and 12, so I'll write that down, and I also do negative 24 and negative 12 as well. And that's just a little shortcut you can use. It doesn't give you like the exact pair, but it just helps you figure out what will work in case you just cannot think of any at the top of your head since it's a big number. But back to the problem. So we've established that some pairs that we can use is 16 times 18. We can use negative 16 times negative 18, 24 times 12, and negative 24 times a negative 12. So let's figure out which one is going to also add to our bottom value, 36. So if we do 16 plus 18, that will give us positive 34, so we'll eliminate that. Negative 16 plus negative 18 is negative 34. so we'll eliminate that. 24 plus 12 is 36, so we'll put a check by that, that works. And then lastly, negative 24 plus negative 12 will give us a negative 36, so we'll eliminate that. So the pair that will work is going to be 24 and 12, so we'll put those in the sides of our x. And now we'll factor. So when we factor, it's going to be in the form of ax plus p times y times ax plus q times y, but this time we're dealing with m and n, so we're going to sub in m for the x's and the n for the y. So when we factor this, the first thing is our leading coefficient a is 9, so we'll put 9 times m plus 24n times 9 times m again plus 12n. From here, we're going to take an extra step and factor both of these groupings, but furthermore, since they're both factorable, so we'll factor a 3 from the first grouping, and that'll leave us with 3m plus 8n, and we'll factor a 3 from the second grouping, and that will leave us with 3m plus 4n. Once we take out those 3's, we can cancel them out and disregard them, and leave what's left, which is just 3m plus 8n plus 3m plus 4n, and that is the answer, and that is how you'd factor this expression. But that pretty much wraps up this video, guys. That is how you factor trinomials with two variables. So as you see, it's very similar to how you do with one variable. And for our next episode, we're actually going to step away from trinomials and start getting into our special binomials. So in our next episode, we are going to be learning how to factor using difference of squares. So stay tuned for that. But other than that, that's pretty much everything, and take care.